All right, so in your planners, you can be writing day 5 homework. Also, remember you have problem set to be working on as well, which is due on day 8. You should have your homework out from day 4, so you'll be able to check it once we go over it in the video. And then we're going to give you 5 minutes to work on the warm-up. I would suggest drawing this picture on your warm-up sheet. It'll make it a lot easier to work with. So again, we'll give you 5 minutes to do this warm-up problem. So we've got 4 arcs here, so they should add to 360. We'll start out by setting up an equation for that. So we want to add up our x's, which we should have 20x, and then add up our constants over here, which we should get 160. We'll subtract the 160 over. We get 200. When we divide by 20, we get x equals 10. So 8 times 10 is going to give us 80 for AB. 7 times 10 is 70. Minus 10 is 60. So we'll get 60 for BC. We already knew CD was 120. And then 5 times 10 is 50. Plus 50 is 100 for DA. So we'll have 100 here. So we're going to find the measure of each angle. What we want to recognize is each of these angles, the vertex is on the circle. So it is an inscribed angle. The new thing we learned on day 4 is an inscribed angle is half of the measure of the arc it opens up to. So for example, angle D, if we follow it, it hits the circle at A and C. So we'll be doing half of that whole arc, which combines the two of those. So if we add the 80 and the 60 together, we get 140. Half of 140 is 70. Maybe if we go over to angle A next, angle A opens up to all of this. So together those add to 180. Half of 180 is just 90. Angle B opens up to the 100 and the 120. So that's 220. Half of that is 110. Then angle C opens up to the 80 and the 180. So half of that is 90. The 80 and the 100 to give you 180, I should say, and half of that is 90. So that's just reviewing that our inscribed angle is half the arc it opens up to. So in 1A, angles in a triangle add to 180. So we need to solve to find that missing angle is 35. And then because it's an inscribed angle, its measure will be half the arc it opens up to, the arc that's labeled the x. So if the angle is 35, 35 is half of a 70. So x is 70. 43, it's an inscribed angle, so it's half the arc. So if you double it, you can get what the arc is, which is 86. And then the central angle at x is the same as the arc, so that's just 86. We have this angle here is opening up to the 132, and it's inscribed, so it's half of it. You get 66. Because it's an isosceles triangle, the other base angle is also 66. And then you can set up a little equation to solve for x, because the angles in a triangle add to 180, so we get x is 48. So a lot going on in question 2. Start by just labeling anything that you might know. Based on that 74 that is an inscribed angle, we should be able to get that that arc is 148. Based on the fact that 28 is your inscribed angle, we should be able to get that the arc is 56. Well, notice then that this angle x is an inscribed angle that also opens up to the 56. So that tells us that x is 28 because it should be half the 56. So the other x should be 28. Well, now in our triangle, we have 3 angles. And by the triangle, I mean triangle DCB. We have the 74. We have these 28s. And then the y is the third angle. So just add those up and set them equal to 180, and then you get y is 50. Based on the inscribed angle of 40, we know that arc is 80. Therefore, the central angle here is 80 as well. Based on angles in a line, if we have 112, the angle next to that should be 68. And then angles in a triangle should add to 180. So 68 plus 80 plus x should equal 180. So we get x is 32. In 3a, just start labeling things that you know. So from the central angle of 60, we know arc BC is also 60. Well, x is inscribed, so it should be half that 60 opens up to, so x is just 30. B was a challenge problem. Okay, if you had trouble with it, it's okay. So some things that we know. Based on the central angle of 60, we get that this arc is 60. Well, if this arc is 60, the inscribed angle has to be 30. From there, we know that these radii are congruent, so these two angles should be the same. Based on the fact that they gave us that this was 50, we know angles in a triangle have to equal 180, so this is 100. So its vertical angle is 100. We also know that this is 80 here. So some things that we can figure out is this has to be 20 because angles in a triangle have to add to 180. Well, and then because it's isosceles, this whole angle here, x plus 20, has to equal that one, so we can call that x plus 20 as well. And those along with the 60 have to equal 180. Well, from there we can solve to get that x is 40, and that's what we were looking for in the problem. So that's pretty tricky. And again, that's why that was a challenge problem. In C, you have an inscribed angle of 30, so this is just 60. Central angle would then be 60 as well. We have parallel lines, so by alternate interior angles being congruent, this is 30, meaning this has to be 90. And then by angles on a line adding to 180, x has to be 90 as well. All right, that's it for the homework. Let's flip over to page 32 and have your calculators out. So we're going to learn several new rules today, but first, a couple pieces of vocabulary. A secant line is a line that hits the circle in two locations. A tangent line is a line that hits a circle in only one location. And you have those each demonstrated underneath the paragraphs there. So a secant line on the left because it hits it twice, tangent line because it hits the circle in only one location. So the first thing we're going to look at is when you've got two intersecting lines inside the circle. Any of those, you're essentially doing the same thing. So let's just look at one of them. Let's say we wanted to look at angle 1. Well, to find angle 1, which is this one here, you're just taking arc AD and arc BC, adding them together and taking half of it. So the way I like to think of it is when you have lines crisscrossing inside, and note they're crisscrossing and not at the center, because if they're at the center, they'd just be a central angle and be equal to the arc they're opening up to. But if they're crisscrossing and not at the center, all you do is you add the arc it opens up to and the arc its vertical angle opens up to, and then take half of it, and that gives you the angle. So we're going to skip ahead and come back. So skip ahead, I think 2 pages. So let's see, that was bottom of page 32. So skip to the top of page 34. And we're going to look at 1A, and we'll apply an example of that. So in 1A on page 34, notice we've got crisscrossing lines forming an angle. Well, our angle, x, is always equal to 1/2, and then in parentheses, the sum of the arc that our angle opens up to, plus the arc that its vertical angle opens up to. There's its vertical angle, it's opening up to 40. So angle x is just half of 80 plus 40. Well, 80 plus 40 is 120, and half of 120 is just 60. So x would just be 60 degrees. So it's basically averaging the arc that it opens up to and the arc that its vertical angle opens up to. So let's flip back to the top of page 33. And we'll look at our next rule for today. So in this picture, what we have is a tangent, which would be AC, because it's hitting the circle in one spot, and either a chord or a secant. And they're meeting on the circle. Well, this is really just a special inscribed angle. Because the vertex is on the circle, this angle here should be half the arc. So angle 2 is just going to be half of arc BGD. And angle 1 will just be half of arc BED. So for example, if I told you that this arc here was 220, because angle 1 is just a special inscribed angle, its measure would just be half of that, 110. And then to get angle 2, there's two ways you could do it. You could do angles on a line add to 180, so that could tell us that this is 70. Or you could say, okay, all the way around the circle is 360. So if we have 220 there, that would leave us with 140 here, and then half of 140 is 70. So the tangent meeting up with a chord or a secant on the circle really just forms an inscribed angle. So it's like what we did in the last lesson. So to practice this one, let's jump ahead to page 34 again, and we're going to look at the middle question, question B. So notice angle x, its vertex is just on the circle. So it's a little different looking than the ones we saw yesterday, but it's still the same idea. X is just half the arc that we open up to. We're opening up to 100, so angle x is just 50 degrees. So that's our second new rule for today. If we go back to page 33 at the bottom, we'll learn our last new rule. So our last new rule, you could have either when there's two tangents, or a tangent and a secant, or two secants. And when you want to find the angle that is outside of the circle here. In all three of these cases, we do the same thing. We just do half of the difference of our arcs they open up to. So you do the bigger arc minus the smaller arc, and then take half of it. And you'll always do that anytime the angle is outside of the circle. So let's go over to page 34 and see an example of that. Notice in question C, notice the angle is outside the circle. So to find x, we would just do half, and we do in parentheses the bigger arc it opens to, the 140, minus the smaller arc, 30, and we'll just see what that gives us. The 140 minus 30 would give us 110, and then half of 110 is just 55 degrees. So pausing on this slide for a second, these are our three things for today again. So A, we had when you have an angle formed by crisscrossing lines in the circle, your angle is equal to half of the arc your angle opens up to and its vertical angle. B is just a special inscribed case, so it's just half the arc. And then in C, anytime the angle's outside the circle, you're going to do a half, and you subtract the arcs. Make sure you do the bigger minus the small. So inside the circle, they add. Outside the circle, it subtracts. All right, so in D and E on the bottom of page 34, notice they are both outside of the circle. So to find angle x, we're going to do 1/2. We'll do the bigger arc that it opens to minus the smaller arc. So that's going to be 1/2 times 70. So x is just 35 degrees. So we'll give you a minute or two. See if you can do E, should be very similar. So to find x, we would just have 1/2. The bigger arc it opens up to 240 minus the smaller arc 120. So we'd have 1/2 of 120. So x is just 60 degrees. All right, moving over to the next one. So what we want to recognize here, well, first off, we want to find arc AB. So let's call that x. So we're not solving for it, but this involves an angle, the 85, that is formed by lines crisscrossing inside the circle. So let's just peek back. You don't have to flip, but in 1A here, notice we had the angle equals 1/2 of arc plus arc. So we're going to do the same type setup, and just whatever's missing will be the x. So we're going to have our angle, the 85, equals 1/2 of arc plus arc. So we're going to divide the 1/2 out of there. Now dividing by 1/2, and you could just do this on the calculator if you want, but doing keep, change, flip, dividing by 1/2 is the same as multiplying by 2. So this is really just going to be 170. And then will be equal to x plus 50. So subtract the 50 over, and we get 120 equals x. We'll end up with 120 degrees for AB. So just label what you're trying to find, a variable that's not in the problem, decide which of our scenarios we have, do the setup, and then solve wherever x is. Sometimes x will already be by itself, sometimes you might have to rearrange it. Now you could have distributed the 1/2 if you wanted also, and then solved for x, you would have gotten the same answer. All right, to start out, we want CBD. So that's this angle here. I'm going to call it X. And then we want ABD. I'm going to call it Y. Well, these are angles that are on the circle. They're just special looking inscribed angles. So it's just half of the arc. So half of 232 would just be 116 degrees. And then there's two ways we can get Y. 180 minus 116 can give us angle Y. So that would be 64 degrees. Because angles on a line have to equal 180. Or we could have done 360 minus 232, and that would have given us 128 here. And we could have done 128 divided by 2 to get our angle ABD as well. So here we're just going the reverse. If we've got 125, the angle next to it must be 55 because angles on a line add to 180. So major arc TR is the one that's bigger than 180. So that's the one kind of on the left-hand side of the circle. Minor would be the one towards the right because it's less than 180. So we've got our same scenario we just saw before, but we're going reverse. So this 125 should be half the arc it's opening up to. So to get the arc, we'll just double it. So we get 250. And then to get part B, we can do it one of two ways. We can double the 55 to get 110. Or once we knew we had 250 for the first one, we could have done 360 minus 250 to get 110 for the remaining arc. All right, start by putting an X for the thing that we want to find. So we want to find AB. What we want to recognize here is that we're dealing with an angle outside the circle. So when you do with an angle outside the circle, you start with your angle outside, and that's equal to 1/2 of the bigger arc minus the smaller arc. And when we say bigger arc and smaller arc, we mean the arcs it's opening up to. Think of that angle as like a big mouth, and it's eating up 2 of the arcs. So the purple arc is the bigger arc, so we should start with that. And then we're subtracting off the smaller arc, the green one here. So we'll start, let's divide by 1/2. We saw in the previous, or a couple problems ago, dividing by 1/2 is multiplying by 2. So we have 110 equals x minus 15. And then we'll just add the 15 over to get 125 equals x. So again, we had to recognize that we were working with an angle outside the circle. So it's the angle equals 1/2 of arc minus arc. And make sure it's big arc minus small arc. We've got an angle outside the circle. So we're going to do the angle x is equal to 1/2 of arc minus arc. So again, think of that angle as a mouth. What are the arcs it's opening up to? Well, there's the big arc it's opening up to. The little arc is this one here, which we don't know. So to figure it out, let's call it y for a second. We can do 360 minus 141 minus 43 minus 162 is equal to y. So take a moment to put that in your calculator, see what it gives us for y. And we should hopefully be getting 14 for y. So we'll just fill 14 in here. Notice x is by itself, so we can just sub that in the calculator. So go ahead, sub in the right side there. And we should get either 29/2 if you left it as a fraction, or that's 14.5 degrees. We want to find BD, so let's call it x. Label the thing you want to find a variable. We want to recognize that that 80 is outside the circle, so we want to do our setup when we have an angle outside the circle. For that, it's always the angle equals 1/2 of arc minus arc. So again, think of that angle as a big mouth. What is the bigger arc it's eating up? It's this one, the 200, minus what's the smaller arc it's eating up? It's the x. And then we'll just go to solve. So we'll divide both sides by 1/2, which is the same as multiplying by 2. So we get 160 equals 200 minus x. We'll subtract the 200 over. We get negative 40 equals negative x. And if we divide by negative 1, we get 40 degrees for what we called x, which is what we wanted to find, the BD. So we want to recognize here that we've got an angle outside the circle. When you have an angle outside the circle, just like we saw in the last one, it's angle equals 1/2, and in parentheses, big arc minus small arc. We'll notice our angle's eating up both arcs. There's only 2 arcs here. Our big arc is 310. Well, they didn't give us the smaller arc, but we know together they should add to 360. So if you have 310 for that one, 360 minus 310 gives us 50 for this one. And then x is already by itself. 310 minus 50 will just give us 260. And 1/2 of 260 is just 130 degrees. So now number 9 is the hardest problem we're going to see so far. So notice in the last one that when you only had 2 arcs there, we knew they had to add to 360. Well, they want us to eventually find the measure of FG major. Well, we know that FG major, the big arc, and FG minor, the small arc, both have to equal 360 when you add them together. So what I'm going to do, let's call this one X. Because that one's X, we know the other one has to be the leftover from 360. So we're going to call it 360 minus X. So for example, if X was 60, the other one would be 300, because together they should add 360. We have an angle outside the circle, the 40. So we're just going to do our setup for that. The angle is equal to 1/2. And then we'll have big arc minus little arc. So 360 minus X. That's the big arc. And then minus X for the small arc. And now we'll go through and solve. So if we divide both by 1/2, hopefully by now we know that that's multiplying by 2, so we get 80. I'm going to combine some like terms and make this be 360 minus 2x. If we subtract our 360 over, we're going to get minus 240. Nope, I take that back. Minus 280. Is equal to minus 2x. And if we divide by -2, we're going to get 140 equals x. Now, I purposely had x be minor FG, so we wouldn't have to worry about distributing a negative. But we just need to be careful because x was minor FG and we want to find major FG. So to get the answer that we want now, we've got to do 360 minus 140. So we end up getting 220 degrees for what we actually want, the major FG. All right, so our last slide, we'll look at these 3 to finish off. So these ones are a little bit more review, not so much from today. So there's 2 ways we can do A. One, we had a rule from the other day that if you have a quadrilateral, meaning a 4-sided figure inscribed, that the opposite angles had to be supplementary. So knowing that, we could just get that this is 95. Now let's say you didn't recognize that. Because of the 85, which is inscribed, we know that this arc has to be double it. So this would be 170. Meaning the whole rest of the circle should be 360 minus that. So that would be 190. And then angle X, because it's inscribed, should be half of the 190, which gives us 95. So if you didn't remember the rule, you could still figure it out using our inscribed angles. In B, you could do one of 2 things. Probably the quickest way is to recognize that this angle here is inscribed. It opens up to the 40, so it's half of its measure, so 20. Well, we've got a bunch of radii here, and radii in a circle are always congruent. Well, we've got an isosceles triangle. Base angles are congruent in an isosceles triangle, so angle X is just 20. And then our last one, if P is the center, because they're calling it circle P, we know that that line then must be a diameter because it goes through the center, meaning this whole arc is 180. Well, angle X we want to recognize as an inscribed angle because it's sitting on the circle. It is half the arc it opens up to, so therefore X is just 90 degrees. Now we did have a rule we talked about the other day that an angle inscribed in a semicircle is always 90. If you didn't remember that, we can always just get it because it's going to be half of the 180 that it's opening up to. All right, that's it for this video. Any time left in the period, you can work on your homework. Remember, you also have problem set to be working on as well. Have a great rest of your day.